We're back, everybody. Let's do this. The G Money videos are back. Someone, let's hit that green button. It's been a while, but we got this. All right, so for our lovely 9th graders who are gonna all pass that Algebra 1 Regents, what is one question that they will always ask? It's how do you graph this system of inequalities, right? So let's take a look. Let's try and remember the essentials of a system of inequalities, right? But even before that, while you're watching these videos, it's really important to know that anytime you need to, pause and rewind when you need to, yeah? If I say pause and try something on your own, then try that on your own. Grab your popcorn, grab your snacks, and enjoy the show, right? So let's do this. This is the first time we've done a system of inequalities with 2 of them, right? So let's just remember the guidelines, right? What do we want to do? Let's graph one inequality at a time. So when we graph this inequality, the first one, let's think about the blue coloring. And for this one, let's think about the red coloring, right? So what do we need to do to graph the first inequality? We need to graph 3 points, think if it's solid or dashed, test our point, and shade the region that's true, right? So this we should know. Let's look at the first inequality over here of y is greater than or equal to negative 3x minus 4. So what should I do first when you get the calculator? Make sure you reset it, right? Because you don't know what anybody else was doing. So let's hit second plus 7, 1, 2, and poof, the calculator is reset. So let's go to y equals, right? And what am I going to type in, right? I'm going to type in negative 3x minus 4. Okay, so let's just graph this one at first. So then what does the graph look like? It looks something like this. So where do I go to find the points? I hit second graph. And then, wow, look, because it's not a fraction like this one, the points look really nice, right? So let's just pick any 3 points. Which are some good points? Let's look at 0, negative 4. What's another good point? Maybe 1, negative 7. And then we could even do negative 2 and 2, right? So what I want you to do is pause the video for 1 second, yeah? Practice doing this yourself. Let me see if you could graph this by yourself, right? Here are the 3 points. Label your axes, right? If you want, take a second to label the axes. So this is 0, and let me just do this. This is 1, this is 2, and if you need to fast forward this, go ahead and fast forward it. All right, so what were the points I picked, right? Negative 2, 2, so where will that point be, right? Always start at the origin, and remember we're gonna use the blue coloring, right? The blue points will represent this inequality. So negative 2, 2, that's my first point. 0, negative 4. 1, negative 7. Okay, so then what I'm gonna do is grab my very fancy bougie ruler, and then I gotta think to myself, solid or dashed, right? Solid or dashed. It will be solid, right? Don't forget your arrows. And remember, what's the name of this equation? Practice writing it down. Y is greater than or equal to negative 3x minus 4. Right? So you're telling the reader that you know that this line represents this inequality and not this inequality. Right? So we did the first two things, right? Easy peasy. Graph your 3 points, draw the line, now the test point. So what do? I show this inequality, test 0, 0, right? X equals 0, y equals 0, right? Because this is my x and this is my y. What's the inequality? Y greater than or equal to negative 3x minus 4. And I want you to pause the video and try this by yourself, okay? Pause the video, try this by yourself, plug in the values. Is it true or false? Right? Is it true or false? Question mark. And then which side am I going to shade? Right? So let's say you're continuing forward, right? Because you tried it on your own. Well, what do? I have 0 greater than or equal to negative 3, and I'll put a little parentheses over here, times 0 minus 4. Then what do I have? 0 greater than or equal to, what's negative 3 times 0? That's 0 minus 4. 0 greater than or equal to minus 4. Then you have to ask yourself, is this true or false? Is 0 greater than negative 4? That is true, right? This is true. So then what does that mean? If the point 0, 0 is over here, and you see when you look at the line, you have the left side and you have the right side. So if it's true for this point and it's on this side, then what am I going to do? I'm going to shade this region. Right? I'm going to shade this region. So this region represents all the points that are true if I were to plug it into that inequality for y is greater than or equal to negative 3x minus 4. Let's go. Very nice, very nice. Well, we're not done yet, because what do you think we need to do next? We got to graph this inequality, right? So what I want you to do is, you can do this, pause the video, do what you got to do to try and graph this, right? And I will do it right after, okay, for you to check. So let's see. Let's say if you want to check, and if you feel like you want to just fast forward to the part where the solution is, go ahead and fast forward. But if you want to see everything step by step, let's take a look. So what am I going to do? I go to the calculator. I go to y equals. Now let's get rid of this function and let's plug in the other, right? So how do I put in a fraction into the calculator? Alpha, y equals, enter. So I'm going to put 1 over 2, and then I'm going to go to the right side. I'm going to hit x minus 6. Okay, so now if I hit graph, give or take, the graph should look kind of like this on my graph, right? So then I hit second table, and then I try and find some good points, right? So let's take a look. What are some good points? I see 0, negative 6 is a good point. So then what I'm going to do is I'm just going to write some of my good points like over here. So 0, negative 6, that's a good point. What's another good point? 2, negative 5, right? Avoid the fractions. And let's pick a negative number. Negative 2, 7. Negative 2, 7. Okay. So I have my 3 points. If you picked 3 other points, it does not matter. So if I have the first one, which is 0, negative 6, 0, negative 6 is somewhere here. Okay. Then where's the other one? 2, negative 5, which is here. And then I have negative 2, 7. So what's negative 2, 7? Wait. Negative 2, 7. Wait, that's wrong. It was negative 2, negative 7. My bad. Negative 2, negative 7. That would be over here. Right. So then those are my 3 points. And then, oh, what should I do? Solid or dashed? It should be dashed, right? Because you don't have the equality symbol. So then make sure you have something like this. And then also make sure you get into the habit of drawing the arrows. You draw the arrows, and what do I say? Y is greater than 1/2 x minus 6. All right. So now, what do we need to do? We need to test the point, right? We need to test the point. So here, where is the point that I test? Here, let's see. Y is greater than 1/2 x minus 6. So let's zoom in over here. And then what am I going to do? Test 0, 0. Right? Test 0, 0. So if this is 0 greater than 1/2 times 0 minus 6, 0 greater than 1/2 times 0, which is 0 minus 6, 0 greater than, what's 0 minus 6? That's negative 6. So what does that mean? Is 0 greater than negative 6? That is true. That is true. So then what happens is, if that 0, 0, right, this 0, 0 that we tested, if it's here, and notice that if this is the graph, if it is above the line, then what has to be true? That everything above this whole entire line has to be true. Right? Everything above this line has to be true. So notice that you have, let's go back a little bit. This function, where was it true? It was everything here. For this inequality, what was true? It was everything over here. Where is the area that is shaded both blue and red? It's all of this over here. It's like to the right of this blue and above this red over here. So what we're going to do is we're going to write a big fat S within everything within this location, right? This represents our solution set, okay? So the really important thing to ask yourself is, what does the shaded region of both inequalities represent, right? What does it represent? It represents the solution set. What does that mean? What if I were to pick a point in both regions? So what if I pick a point that's in the red and the blue region? So let's pick a point that is not 0, 0, because 0, 0 is in both regions. Let's pick another one. Let's pick like 2, 3, right? You see how this point 2, 3 is in both the blue and the red section? Let's identify this as my point, right? So algebraically justify why the point you picked satisfies this system of inequalities, right? So let's take a look. Let's write the first inequality, which is y greater than or equal to negative 3x minus 4, and the other one is y is greater than 1/2 x minus 6. What do you think we're going to do? What are we going to replace for both x and y? This is my x and this is my y, right? X is equal to 2, y is equal to 3. What I want you to do is plug in x is equal to 2 and y is equal to 3 to both inequalities by yourself, pause the video, and see what happens. See what you get. Okay? So now if you want to see it, let's see. It'll be 3 greater than or equal to negative 3 times 2 minus 4. And what about over here? I could say 3 greater than or equal to, what's negative 3 times 2? That's negative 6 minus 4. Then this is 3 greater than or equal to, what is negative 6 minus 4? That's negative 10. Okay, well what about for this one? This is 3 greater than 1/2 of 2 minus 6, right? Because x is still equal to 2, right? X is still equal to 2. So 3 greater than 1/2 of 2 is 1, and you could put this into the calculator if you want to just double check, right? 1/2 of 2 is 1 minus 6. 3 greater than negative 5. Now what you have to ask yourself, is this true or false? Right? Is this true or false? Pause the video, take your time. What do you notice? Right? What do you notice? Is 3 greater than or equal to negative 10? That is true. Is 3 greater than or equal to negative 5? That is true. You see, what's happening is if I pick any point in both the red and the blue region, if I plug in any point into both inequalities, it will be true. If I plug in a point over here that's in red, and remember the red is this inequality. If I plug in a point over here, do you think it would be true over here? You could test it, but it won't be. And that's the lesson for today. What I'm going to do is I'm going to give you one question that's going to be similar to this, and you got to try it on your own. Let's go.